The next talk is Hunting for Bugs, Catching Dragons with Nicolas, Joly.
Thanks. Well, believe it or not, I am super excited to be here on the stage before you. Even if I don't sound that excited, I am excited. Yes, my name is Nico. I'm French. I work in the UK for Microsoft at the Microsoft Security Response Center. I'm part of the Vulnerability and Mitigation team, the VNM team. And to be fair, I'm doing more vulnerability research than mitigation. And that's surely one of the reasons why I'm here today. I'm here. So I'm going to talk about email security today. So by the end of that talk, I'd like you to know much more about email security. I'd like you to become experts in this area. So hopefully you'll be learning things. For those of you who have already hacked into Outlook, I'm sure you will be learning things, new things. And for those of you who have already written Outlook exploits, well, I'd love to meet you. So please come to see me after the talk. I'm sure we've got lots of stuff to talk together. So here we go. So I divide that talk into two parts. First part on Outlook. So I'm probably going to spend 35 minutes on this, and then another 10 minutes roughly on Exchange. I have demos, I have bugs, I have exploits. So hopefully you'll enjoy it. And you know what? For once, I'm going to start my presentation with a demo. I assume that you guys are not too familiar with Outlook exploits. So think about that for a second. What do you think is the worst case scenario for Outlook? An attack in the preview pane, maybe? There's even worse than that, guys. There are some attacks on the sync engine. You send an email and you don't even need to read that email and you get owned. That's one example, for example. These are the dragons that I want to catch. You know, the big bugs, the big issues. So let's pretend for a second that you've never seen this demo. Let's say that didn't happen. Let's come back to time. If I mention Outlook exploit to you guys, so that sound familiar? Probably not. So in my opinion, in my memories, the last time we heard about something like that, I mean something widespread, something used in the wild, that was probably 20 years ago with these IW bugs, these IW worms, where somebody would send an email with an attachment, a VB script attachment, you double click that attachment, and then you'd get out. There was something interesting as well. I think it was in 97, something like that. A virus named CAC. It was spreading with JavaScript signatures embedded into emails. That was cool as well. That's probably where I started in the InfoSec, by the way, about that time. So more recently, exploits that we've seen. We've got one interesting submission, awesome submission by Heifei about 3-4 years ago. So he managed to get code execution in an email by embedding a Flash exploit in that email. So he found a way to insert a Flash control to send it, and then he was using a known Flash vulnerability to show code execution. So that was great. There was somebody else, Ryan Hansen, about 3 years ago. At that moment, you know, there are these days at the MSRC when suddenly you receive an email and there are like, I remember that day, we got 3 cases and I looked at them, I checked the queue, I was looking at those cases and read them all. And I thought, if only half of this is true, well, this is seriously bad. It turns out that he was right on the 3 of them. So kudos to Ryan Hansen and more bugs like this, please. I'll come back to some of them in a moment. And then there are also the last ones. The ones, the exploits for which people don't really know that there is an Outlook vector. I'm thinking, for example, about these exploits that attacked the font parser, the EPS font parser back in 2015, 2016. So in that case, the attackers were using a Word document to to spread their, well, to attack people. But nobody realized that you could carry this attack just over an email. I can tell you now that it was actually possible to do this. So that leads us to think about the attack surface. What's the attack surface for Outlook? It's huge. It's actually a warehouse. Think about email parsing or emails like HTML emails, calendars, rich text emails, objects that you can embed in an email, fonts, pictures, lots of things. Think also about the protocols, the SMTP protocols, POP3, IMAP. I was checking Heifei's slide recently at CanSec, and he was mentioning that, for example, in 2013, something like that, we fixed an integer overflow affecting the POP3 protocol. That was interesting. That would assume that your client Outlook is dealing with a tampered server, or that somebody is doing some man-in-the-middle attack, but still, that's a legit attack. We've got also everything that touches the cryptography, like spoofing attacks, anything that touches certificates. Can you hack the certificates? Can you attack the crypto? Yeah, why not? And then there is also, well, I'd call that the remaining parts. So we are dealing here with an Office application, so of course there are macros involved. So say, for example, that you've got an email that somehow manages to trigger macros. I'm just inventing that, guys. I've never seen this, and hopefully that won't happen. But just like this. And also think about sense post ruler. So here the scenario was that you've got an account that has been compromised, and how can we leverage that to get code execution on the client, on Outlook. Interesting attacks. Today, I've got 40 minutes left. I'm only going to talk about these few points. Rich text, attachments, Joly objects, and of course, TNEF. So before I start talking about that, you might be wondering why I'm doing that. I'm from Microsoft, and I'm literally going to teach you how to hack into Outlook. So you might think that that's a bit weird. I've got my reasons. I'm after these dragons. And the thing is, we barely receive cases, like astonishing cases. We know these exploits exist. I mean, there is that zero-day bug bounty at $200,000, for example, for an exploit affecting Outlook. I'm not getting these cases, so we are there. So why aren't researchers reporting these bugs to us? Because they are there. I've seen some. Is this because, I don't know, there isn't that much of research out on the internet? Is it because, well, there's no symbols in Office? Sorry, I can't help you on that, but yeah, things happen. Lack of interest in the area? I don't know. But how can we help our finders? Let's just talk about one research and talk about some of the cases we got. So quick disclaimer, of course, all the bugs, the vulnerabilities that are discussed in the following slides have been fixed. Let's go. TNEF, does that sound familiar to anyone? I'm pretty sure that some time ago you received an email with a weird attachment named winmail.dat, and you're like, what is that thing? What is this about? And then you start Googling a bit about that, and you find blog posts saying, oh yeah, it's because Outlook isn't well configured, and so it's sending its proprietary emails, and so you can't decode them, etc., etc. All of this is related to TNEF. I borrowed that slide from Heifei because when you look at TNEF in Google, that's one of the first pages that appears. What is this TNEF? So you read this and you see that it can contain all the objects, attachments, and you know what? Special Outlook features. And you know what? These are the ones that we are interested in today. So what's a TNEF email? The specs are there. So I'll come back to that in a second. So let's say that you receive an email from Outlook. You look at it. You look at it on the server. Sorry, one click to me. Where am I here? Oh, here. So you look at it on the server and you see that there are some MIME headers followed by an attachment encoded in base 64. The MIME type is application MSTNF, and you're wondering what is this thing. So you decode it, base 64 decoded. Do I have an issue with my clicker? All right, I do this. Yeah. And then it turns out that now we are dealing with a file format. So what's this file format? So the specs are open. You can find them on the internet. So it's basically a sequence of objects, containers, and properties. So I've written an 010 template for this. It works. Am I going to publish that? Maybe. So you know what, guys? Here's the deal. You find me a good bug in the TNF, I blog about it, and you'll get that template. Deal? Sounds good? We'll do that. TNF or rich text. So often people, often we tend to mix a bit. There's two things. So when we say we're going to, when you compose a rich text email, you've got the feeling that you're actually going to send a rich text document on the wire. That is not entirely correct. What you're doing is that you're saying a TNF email, and one property inside is the RTF document. So that special property. So there are various encodings for this one. The most common is the compressed one. So it starts with LZFU. So that's a compressed structure with a custom algorithm. And the other one is the meta. So I'm not aware of any possibility in Outlook in the UI to generate these emails, but just be aware that this exists. So why am I talking about that? Because we still receive cases for Outlook. People, for example, fuzzing the MSG file formats. And when they do that, they fuzz literally with a shotgun, trying to flip bits. It works because sometimes we've got interesting cases, but it produces so many invalid files. So if you're interested into fuzzing the RTF part, just do something else. Use the interrupt library, for example. You can just build an email with C# and just say that you're going to use your own corpus of RTF files, and that will give you much less issues. And I'm pretty sure that you'll find new bugs, and so you can report to us. Coming to the RTF issues. So think about that. Outlook is using the Word core library to parse these RTF emails. So that means several things. That means that if you have an issue that affects the RTF parser, it probably affects Outlook as well. And that's the reason why we're still shipping built-ins with critical severity. Because sometimes you've got an issue that affects Word and also affects the Outlook preview pane. So here you've got a zero-click attack. So think about now attacks that could potentially work on Outlook, but could be legitimate scenarios in Word. And that's probably what Ryan Hansen thought at the beginning of his research. He figured out that since Outlook was parsing the RTF file formats, he was probably also parsing everything that Word was parsing. For example, that template keyword. I am not aware of any possibility in the UI to generate an email that embeds a template file. So what's the problem here? Well, if you use a template keyword, you're gonna ask Outlook or Word to load a template for you. The problem here is that the file is the path to that file is controlled by the attacker. So you can put an HTTP path, you can put an SMB share link, or you can even put a local file. And that's what Ryan Hansen abused. So what he did is that he put an SMB link to an external file, and he figured out that if by doing so, he was still able to load Flash. So this attack was reported to us about a year after Lee reported his bad windmail attack. So he found like a misvariant. So the problem is that obviously when we got high phase attack, we didn't realize that it was also possible to trigger the same issue with this template keyword. But think also about all this implies with, for example, these SMB links. If you do that, then chances are that you're going to send the NTLM hash, for example, over the wire. And people have been known for years that this is an interesting attack vector. There's even worse. I think about all the supported file formats. So all of a sudden, everything that Word parses becomes available in Outlook, which literally means that any vulnerability that affects Word will be triggerable from the preview pane. So all our bugs which are rated important in Word should then be considered as critical. I'll give you another example with the template keyword. This one's a memory corruption. So you just specify a template that refers to another template, which in the end will refer to a template with the same name, but with a path that is invalid. And then you'll get a UAF. So you see all these issues with the template keyword. And what do you think happened to that template keyword? Support was dropped. I'll come back now to the Outlook interrupt library. It's probably the best way if you want to play with Outlook's custom functionalities. It's really easy. Everything is documented. You can find that online. And you've got some examples about sending normal emails, valid emails. And if you look at the specs, you'll see, for example, the message class property. So this is just specifying the class of the email that you'll send. So try something, just send an email with that library and use the IPM.contact class name. And in this case, what will happen is that instead of receiving your normal email, you'll get instead a contact in the preview pane. And the first time I did that, I was definitely not expecting this. So you've got several classes. All of them have their own properties. For example, this contact form, it's interesting in a way. You can see there is a picture on the top right corner. Emails can embed pictures, that's fine. But this one is particular. This one is actually using the GDI stack. Outlook, usually when it parses pictures, is using his own stack, the MSO stack. But with this one, if you find an issue with the GDI stack, then you'll be able to abuse it directly in the preview pane. So those are things that can be interesting when you want to build attacks. I give you a short list of other classes, like tasks, calendars, of course, etc. There are lots of them, so here's a link where you can find others. There are even some that are undocumented. How to find them? Well, you guys are reverse engineers, so you probably are pretty good at doing that. Just find string in binaries. So I give you now an example of something that we received quite some time ago, the IPM remote message class. So this was reported to us by Etienne Stallman at that moment. He was just generating a normal email, and he was changing the message class to IPM remote. And what happened is that at that moment, when you loaded that email in the preview pane, when you saw that email in the preview pane, you would trigger a null pointer. So we are not really interested by that. So that's why this was fixed in vNext. But well, still it made its way to this presentation, so it was quite cool at that moment. I'm now going to spend time on something else, something that Ryan reported us, the IPM.document class. So the attack that he reported us was a protected mode escape. So in this case, he was giving an example, a .message file, where the email would have two attachments. One was a regular RTF file, and the other one was built from his shenanigans. And it turns out that when you were opening the regular attachment, Word would open within app container. But if you were doing the same with the other attachment, then Word would load with medium integrity. And I'd like to mention another CVE where emails can just show by default Office documents. So I'm now going to show you a demo with both CVEs combined. So this attack is just about sending an email. The attacker sends you an email, you receive that email, and a war starts. And if you look at it with Process Explorer, you'll see that wars run with that container. So now by default, you've got all the world formats, all the world vulnerabilities available from the preview pane. And the thing is, if you open that mail manually, you'll see something different. You'll see that another word process has started, but this time it was started by the automation. You can see that it was run by the service host. So automation makes you think about class IDs, things like that. So if you look at TNF details, you'll see that there is, in this particular case, there was the world class ID stored somewhere in a file. So what happened if you change that class ID to something else? Let's say the class ID of the equation editor. That's fine. It doesn't run in the preview pane. But what happens if you double-click that email, if you just open it? Here we go. So think now about the equation bugs that we got 2 years ago, something like that, which were amazingly reliable. Yeah. So this is something that was triggerable from the preview pane as well. Going to talk more, not from the preview pane, sorry, but just a click away. Going to talk more now about Joly objects. So first, how to create message files. Everything is all interconnected. So you can either use Outlook click and paste on your desktop, and that will generate yourself some nice message files, or you can use the interrupt libraries. I'd advise you to take that one because you can then get custom properties with this. And then what happens is that if you open that storage with an Joly storage, you'll see all these streams and sub-storage. So what are they? So what's the relationship between those formats that Outlook support, .email and .msg? .email, we just saw it with TNF. So be aware that TNF property has like 3 characteristics. So it's PID, it's type, and of course its value. You can see them also in the message storage. Look, for example, for the property stream. In this stream, you'll see a list of properties, all of them encoded on 10 bytes. I give you one example here. For example, this one, it ends with O3, so that means we are dealing with an integer. So these are respecting the prop var types. So if you're familiar with that, there's no surprise. There are 3 for integer, 8 for strings, 9 for objects, etc., etc., etc. And here, 1F for Unicode strings. And since these properties should only be stored on 10 bytes, if you've got a string or a byte array, then obviously you need more space. And that's where you see, that's the reason why there are all the sub-storages. Joly object, no. Everything is interconnected, as I told you. So if you embed an Joly object in an email, you'll see something like that, roughly. You'll see a new substorage which ends with OD, which is the var type for VT unknown. And then you'll see also all the substorages. So you're curious, you know about Heifei's attack embedded a Flash object, and you know if you've seen his talk in CatSec, in CatSec 2017, he said that after the fix, something weird was still happening. He said that he was still able to load the Flash library, but for some reason his payload wasn't loaded. So you want probably to dig a bit this area. You want to see what's happening there. So I appreciate that you don't have the symbols for Office, but you do have those for Windows. So here, just put your breakpoints on the usual suspect, read class name, Joly open storage, etc., etc. And you see where I'm going. In the end, you will reach Joly load. And if you've looked at the exploits that we received in the past years, those were invoking monikers. And You see where I'm going now. How to invoke monikers from an email, just with Joly load and modifying that Joly stream. So when you do that, you're going to reach one function, read moniker stream, which is just going to co-create an object for you and bind it to the hypersys stream. Yeah, Joly load from stream. Sorry. So I give you now a few examples of these monikers, how you can abuse them in Outlook. So there's our friend, Will Dorman, who reported us a bug about 2-3 years ago, something like that. What he was doing, he was using Outlook, I think 97, maybe 2000, something very old. He was inserting an object in that in his email, and then he was linking that object to remote share. So his concern was obviously that when this email was open in the preview pane, then you would see some traffic, you could capture an NTLM hash, etc., etc. And then he figured out, and what if I combine that to an SMB vulnerability? And this is what he did. So that was cool. He had his BSOD, and yeah. So this is not the best attack, but that's still a good attack. A bit more with the find moniker. If you've ever reversed it, there is a function there that is called, whose name is restore shell link. The thing is that with the find moniker, you can even invoke Windows shell links. So if you've got a vulnerability affecting the shell links, you can trigger it from the preview pane. Here's an example of something that I found a couple of years ago while doing some totally different research. I was looking at links, and specifically links generated by the Windows research feature. And it turns out that when I found a bug there, and I realized that all of this was connected with the find moniker. And so I realized that it was possible to embed that in an email as well and trigger it from the preview pane. Things that I haven't tried are there's bugs, there's load library issues that affect that were affecting the Windows shell component. I'm wondering if this works in an email. I haven't tried that, but perhaps, maybe. I give you another example now of the objdref moniker. So I did that research in summer 2016, and at that moment I wasn't aware of all you could do with this moniker. I'm thinking, for example, about James attack with the new moniker. I'm thinking about the SOAP moniker exploits that we've seen. I didn't know about that, but I'm quite happy actually that I took this one as a target. You'll see. So what's this one? This one allows you to unmarshal an object from the stream, an object that was marshaled with a proper marshaller. It's going that way. Still far from calc. So in this attack, I know that I'm able to unmarshal something from my email, but what? I can call co-unmarshal interface on something. I've got a list of objects, of libraries that I know can unmarshal objects. So what I did was just go after them one by one and see if I could see something interesting. And I stumbled upon this one, the video control. And if you look at the C component types control, you'll see that on the load method, it's taking a counter and then it's iterating in a for loop. It's just reading streams and co-creating an object on the hypersys stream init this time interface. And if you're familiar with Flash, you'll know that this is what Flash used to be initialized. So at that moment, I knew that I was able to load a Flash, the Flash control and potentially find a Flash 0 day to get code execution. Well, I was at Microsoft for about a year, and at that moment, somebody told me, Nico, you're at Microsoft now, so you need to leave Adobe alone. You have to find bugs in Microsoft products. All right, fair enough. So I did something else then. I found another control. I found the XML feed moniker. How did I find that one? Well, no secret, actually. There were about like 7,000 controls on my machine. I just loaded them all with some HTML, with some scripts, etc., until this one popped up. And this way, I managed to execute a VB script from my email. I was still just a bit away from my code because I couldn't use, for example, the file system object or stuff like this. So at that moment, well, I used VB0 because, well, you know, there are some. So what's interesting in these attacks is all the bugs that have been fixed after. So the video control, for example, I've been told that bugs affecting the unmarsher are very important to Windows, and so 3 of them got fixed. Also, for the COM activation filter, we got rid of the XML feed moniker, one that I just mentioned, and also the objdref. I think you can still load it from Visio, but that's probably another story. Do not load objects in the pane. I'm not saying the preview pane here. I'm just saying the pane. Because it turns out that when you reply to an email or when you forward an email, you're going to hit a different code. And there were cases where you could get code execution with an Joly object, like, for example, by replying to an email. No longer possible. Fix another VB script dog. I don't have the CV, but anyway. But what's worth mentioning is that nowadays on C2R, it's no longer possible to load VB script DLL. And also restrict objects loaded by the diagnostic service. And if you followed this presentation so far, you should be like, what is he talking about? Think about the common marshalling. This is extensively used by the system everywhere. Variants, when they are sent from one process to another, they are marshaled and then unmarshaled. That's the same for safe arrays. So now think about safe arrays. When you use something like that in your code, you're not specifying the type of the array. You're just saying that this method accepts a safe array, and then you do your check. Say that you have got a method that's going to parse an array of strings, then you accept a safe array, and then you check only in the method that the safe array is actually contains strings. But the thing is, at that moment, the attacker can provide whatever. It can provide integers, can provide objects. That check is done after these objects have been loaded. So the question is, can I find an application that is interesting for an attacker perspective that can load these objects? It turns out that there is at least one that exists. There is a Flash broker, but Nico, don't do Flash. Okay, I don't do Flash. This diagnostic service, I didn't know about it. Upon 2016, Loki Hart, he pops out. Was it IE Edge? Don't remember. But anyway, the privilege escalation bugs was super interesting there. It was just a load library to get system. And when you look at that, you're like, how am I supposed to know that these things exist? So this is how I became aware of this component. And you know what, this component, it implements one method called getGraphDataUpdate. And this method is quite cool because it accepts a safe array. And the only thing that it accepts a safe array makes it the target that I was after. So I've got a demo for you. So it's just about sending an email and then viewing it in the preview pane to get your code execution. It's not instantly because, when I did that drop, I was just looking after a create process, something easy. So it takes like a couple of seconds to pop, but still, yeah, that works. Is it an attack that works only on my box because it's memory corruption? No, it does work, and I've experimented that on a couple of my colleagues, and I've been told not to do that again, so I haven't done it again. So that's it for Outlook. So I hope that you enjoyed this part, learn some things, and hopefully that this sparked your curiosity. I'm now going to talk about Exchange. So my main issue when I'm going after new targets is to find attacks that have been seen in the wild. Say that I'm unfamiliar with that target, like Exchange. When I started to look at it, I've never looked at it before. So I'm like, how am I going to approach that? So first, you try to look for attacks that exist, bugs that have been previously fixed. There aren't that many. I think it's worth quoting the Shadow Broker's Englishman Dentist exploit. This one was affecting Exchange 2003 on Windows Server 2003. So we're in 2019 here, so you can see that dates. But basically the attack was you were sending an email carrying a weird attachment, a picture, and then on Windows Server 2003, there were in Joly32 a weird method that was parsing Mac pictures, and then there was, I think, Stack Overflow there, and this is what they were exploiting. Well, it works, but on very former versions, old versions. I mentioned about something that ZDI sent us last year was quite good, unfortunately not email related, but still that attack, it's been blocked on their website, so go have a look if you're not familiar with it, but it was involving a voicemail message, so it makes it quite cool as well, but nothing related to an email attack. Unfortunately. So think about the scenarios here. What are we targeting exactly? Are we playing authenticated? Do I know of my account and am I trying to escalate my privilege? Or am I going completely unauthenticated, sending emails and hopefully triggering a bug that will give me code execution? Am I replaying tokens, playing with some web issues? Nowadays, Exchange is pretty much entirely coded in .NET, so that leaves a very small room for memory corruption. Is it still possible to do that? Well, there are still a couple of components that were written in C, C++, and for example, XRPC 32. I'll come back to that in a second. But there are some tools, of course, MFC Mappy. If you've ever looked at that, it's a very powerful tool that allows you to open your mailbox on Exchange. So you can see all the properties for an email. You can see objects. You can even see hidden content tables. And this is super useful because there's even a feature where you can drop these objects as an email file or a TNF file. So if you're, for example, looking after a corpus of file, you can use that tool and drop these TNF objects on your drive. I found a couple of bugs just using that, properties that had been written by some application, either Outlook or Exchange, and that were available on the mailbox, but I wasn't able to load them to create them just from an email. But it turns out that they were there, so I just dropped them and then replayed them, and yeah, that was enough to get some bugs. So think about it if you look at it. Now let me come back to XRPC. So that's one of the very few libraries that are still coded in C++, C++. When I looked at that, when I started to reverse that code, I quickly noticed that there were a couple of functions that were parsing TNF properties. So I was like, yeah, this is exactly what I'm looking after. And then what I'm looking for. And then you start to realize how the code is formatted. So basically they are doing checks on the properties. Like you've got properties, like string properties, for example, you're only accepting ANSI strings or Unicode strings. If you provide something like an integer, it gets rejected, and it gets done for pretty much all properties. All the properties, but two. So the first one I'm going to talk about is the one called the conflict entry ID. So on this one, there was no type check on the property. So this one is specifically accepting a byte array. This is a byte array property, and you can see in this code that it's calling EC parse entry ID, and this function explicitly accepts a byte array in Argrant. So what happens if, for example, you give it an integer? Well, you get a type confusion. Can you exploit that? I'm skeptical. The reason is that the variants on 64-bit are encoded on 18 bytes in X, and that the first 10 bytes are, well, the first 8 bytes are reserved for the type, and then you could potentially get a confusion between the bytes at offset 8 and at offset 10. But can you get an interesting confusion, something that you can actually abuse? I'm skeptical about that. The reason is that there are not that many types supported by Exchange. So I think it's at worst a dose. And in that case, what happens is that the delivery process just restarts. So it's just a temporary dose. But you can stack emails, and let's say that I send you like 24 emails with this vulnerability. The delivery process will crash and respawn within like 5-6 minutes. So you send 24 emails like this, and yeah, you see you can get a cool DOS. But still, that's not what I was looking for. The other property was post-reply folder entries. And this one, I thought, oh, maybe there's a type confusion here as well, because I couldn't see as a check at the entry point. Well, before. It turns out that you can't do that, because there is a check there. But what caught my eyes was that loop. There was a loop in that code, and I could see that the code here was trying to write data to that property, to the byte array that we provided to the function. The thing is that there was no bound check on one bit. So the attack that I had at that moment, I was able to alter 1 bit on the last entry of the list provided by the byte array. So I've got 7 minutes left. So it must be like a very complicated exploit. So what do you think I did? Anyone? I did nothing. I did nothing because it was just too hard. I spent probably two weeks on this. So let me correct that, 2 MSRC weeks. That means that I'm not entirely focused on that. I'm also focused on saving the world. You see, so that takes time. But in the end, I couldn't manage to get an exploit for that. I've only looked at it on the Exchange 2016. So maybe it's possible to get an exploit for the lower versions. I don't know. I'm again skeptical about this. Reason is some heap specifications. But you know what? I'd love to be proven wrong on this. So if you guys want to look at it and tell me how to do it, yeah, I'd love to see this. Really. Quick note in conclusion, can we still trigger memory corruption in Exchange these days? Yes. Although I was unable to exploit these bugs, at least they prove the concept that these issues still exist. I found some other interesting issues, for example, while parsing the rules, but these needed the attacker, well, to know the credential of that account, so you needed to be authenticated. So that was a bit out of scope, but I was convinced that at least one bug was exploitable. Didn't write an exploit for that. But crucially, what else can you guys find? I'm really looking forward to that. A couple of references. You've got the CV in question for the demo on slide 3 if you want to div that and write your own exploit. And thank you guys. Thank you for your attention. I hope you liked it.